So welcome to our CCNA3 Enterprise Networking Security and Automation class. We're down to the last couple weeks of class, folks. Class ends May 8th. Most of you are on track to finish up on time and in sequence, which is great. If you do have any questions for me, let me know and I'll try to answer them. I've just turned the final exam on for the next 3 weeks, so it's on now through the 8th. The course feedback is on until the 5th of May, and I'll take that out to the 8th if needed. And all the exams are on to the 15th of May. So we've got some leeway here to kind of get you done with things. We are going to talk today a little bit about network troubleshooting, and this is a pretty easy chapter to go over because, again, this is not something that y'all have not done before. I just want to give you some of my ideas on troubleshooting and on documentation and those types of things. So we'll start out with documentation, and this is one of the places where I am woefully inadequate. And I think most people who do networking are woefully inadequate at this because, especially in a real environment, we're so fat going around and putting out fires. Like our data center, we'll have an issue, we'll fix it, and we won't document it. And we'll have the same issue 6 months later and forget how we fixed it. So we need to do a better job in our data center of documenting things that are wrong. And not only that, of keeping up with what's where and IP addresses, servers, what versions we're on, all of that type of stuff. The good news is in large environments, there's typically a type of network documentation software you can use. The big problem there is it's expensive. This stuff is not cheap. So we end up having to pay a lot of money to do it. We really, when I look at network documentation, the biggest thing is it has to be a living document. It has to be something that you take the time, not just to create, but you take the time to maintain. I've seen many people do great documentation at the beginning, or they'll hire a vendor. The vendor will come in, put their network in, hand them the documentation, and that documentation is never updated. Even though 6 months, 6 years later, everything's changed, or a lot of things in the environment have changed. No one's gone in and updated the documentation. Another huge issue I've seen is this: documentation only existing on the network. Think about it. If your network goes down to a cyber attack and you need your documentation, you're not going to be able to get to it. So good old plain old paper is not a bad thing. Now you need to secure it because it is a security issue, but so many people have these great network documentation on their network, and when their network gets hacked, they're not going to be able to get to it. So I think that's something people don't really think about. They've got, oh, I got great documentation. It's in this, I got a file called blah, 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 docx, and we got my documentation, everything's on it. And you'll ask them, well, how many backup copies do you have? Well, it's backed up, via the backup system on the network. Well, what if someone ransomwares your entire network and your backups? You now don't have your network documentation. So I can't stress enough the need to get that documentation into a printed format and into a format that's off-site. Here's just a couple ideas of things. Now, you can also document yourself to death. I don't know if I would get this detailed in my documentation. Now, IP addresses are important. The descriptions, I don't know if I'd pull that out. Now, there's software to do it for you via SNMP, which is better. But this is, a good amount of information. The top information is very important. Obviously, this where it's at, the name of the iOS, the license, those things. All of this could be very useful, but you also need to be careful not to document yourself to death. MAC addresses, yeah, it's good to have it, but is that absolutely a requirement? Probably not on a gig 001, 000 like that, unless you're doing some type of MAC address filtering. But just, it's up to you and it's up to your environment as to how in-depth your documentation will be. This is pretty good here. I mean, it at least does tell you whether or not it's in use or not in use, not in use. The problem with this is, imagine if you've got 400 switches in your environment, the ability to keep all of this documented can be a full-time job. And there may be someone whose job is nothing but network documentation, especially in very, very large environments. And here's servers. So ideas about servers. Now with servers, I actually would want the MAC addresses of the different NICs on the servers. That would be important for a variety of things, but I would keep up with that. The other thing you got to really think about with servers, most of them will be virtualized servers anyway. So almost all of them will have a MAC address that is a VMware NIC of some sort. So be aware of that. Once you are documenting, the other thing you need to do is establish this baseline. And let's think about a baseline. A baseline is figuring out how your network normally operates. I'll give you a great example. Back when I was in really good shape before I got hit by a truck, I would get up every morning, and before I even got out of bed, I would take my resting heart rate. My resting heart rate back then was in the literally in the 30s. It was between 36 and 44. It was extremely low. I was in extremely good shape back then too, compared to now. But if I woke up and my resting heart rate was above 50, I knew I needed to either take a rest day that day and not work out as hard, or I knew I was about to get sick because I had a baseline. As long as I was in 36 to 44, I'm good. As soon as it goes over 50, I better start looking at what's going wrong. I could be dehydrated, I could have a cold coming on, I could be overtrained, but I kept a baseline and knew exactly what my body was trying to tell me. We need to do the same thing with our networks, okay? We need to know normal CPU usage on our servers, normal CPU usage on our routers, so that when something abnormal occurs, we can fix it, or we at least are warned about it. We talked a little bit about SNMP. I believe it was last class. I actually did a little bit of SNMP in the lecture that I put up last week. SNMP can actually give us the CPU usage of our devices, and it can set traps so that after it goes above a certain level, it sends an information, a trap back to the SNMP server, which then will send an email to us. Well, we need to know what's normal to be able to set that trap. So we need to do a baseline. And a baseline, when should you do a baseline? What do you think would be a good idea, Angela, when you're thinking about baselines?
When you're first getting everything configured before you, when you're using like a normal day of network, so you'll know what's odd.
Okay, so a lot of people make the mistake of thinking or trying to grab traffic only in the morning on Mondays or the mornings on Wednesdays and mornings on Friday. What's the problem with Monday mornings at between 8 and 9 o'clock most of the time?
It's when everybody's logging in because they haven't been all weekend.
Exactly. So especially if you're a normal, 5-day a week business and first shift, everybody comes in and there should be a huge spike around 8 o'clock. So now if you were to do a baseline for 24 hours over 5 days, that's going to give you a better baseline. But again, even you need to think of it like this. If you are a 5-day a week organization and most people work from say 8 to 6, 7, let's say 7 to 6 max, okay? If I was doing a baseline, I would want to grab most of my traffic during that day when people were at work. After hours, I would actually do 2 baselines. I do a baseline for normal business hours and a baseline for after hours, because that could be important too, because it could show you if someone's trying to break in your network after hours. But if you were to average everything out over 24 hours for 5 days in a business that only was there from 7 to 6 each day, you're going to have a lot of time from 7 to 5 in the morning when very little's going on, and you may get an incorrect look at your CPU usage, incorrect look at IO, those types of things. A business that's 365, 7 days a week, 3 shifts, they need to monitor 24 hours a day for a couple weeks to see what their traffic is. So each individual business needs to think about their environment and how to get a good baseline for that environment, because they will be very different. I think people forget that. They forget about, the business itself determines the correct way to do a baseline.
That's true. I didn't think about like doing an after hours one, but there's so many people who work outside of that time frame. Then you need to know what's going on in the somewhat evening hours, maybe not all night, but
Exactly. Plus, it would give you an idea. You're going to have people, especially if you have VPN access. Let's say you're going to have some people working on things at night.
Yeah.
But if you had an after hours one and suddenly saw a huge spike in traffic, that's a major warning sign that something's going on with the network.
Yeah.
Especially because, if I learn that your business is a 5-day a week, seven to six, I'm probably going to try to break in it sometime during the night when you're not there. So
Yeah. Nobody's going to catch it.
right. Or they may try during the day to hide with everybody in there. That depends on how they do things. But the big thing there is it would give you a better, I think, doing that, getting that normal business hour baseline and the after hour baseline would give you a chance to really see how your network performs at two very different times and in very different environments.
Yeah, I think so.
Now, a couple things here. They're looking at points of interest. There's multiple ways of doing baselines. Most of it's going to be done with some type of span port and an analyzer to look at data traffic. It could be looking at net flow, looking at flows across the network. But a lot of the things we can do from a command line standpoint are things like show IP at brief, show interfaces, which can also show you the load on an interface, show CDP neighbors, show LLDP neighbors. Show port, show tech support. This is a very useful command we rarely use in the lab, but in the real world, this is a very important thing because it shows a huge amount of information about the device that you can then give to TAC, which is Cisco's support center, and it can be used to help with troubleshooting issues. We've had several times when TAC asked us to do a show tech support and some other show commands and send it to them when we were having an issue. Okay. Now, once you've got a baseline, you're going to be able to do troubleshooting. And I think the biggest thing about troubleshooting is have a process, have a plan. This is one possible way, and I will be honest with you. I do think good troubleshooters can be made, but great troubleshooters are born. There are just those people that I've met in my life who work on networks, who have the ability to almost, it's like the Matrix. They can see the ones and zeros and see people walking by. But everybody can be taught to be a good troubleshooter by using a process. Here's one, gather the symptoms, isolate the problem, implement something to fix it. If it's fixed, document it. If not, undo what you did. And I think that's the key. A lot of people don't think about undoing the corrective action. They end up just piling more junk on top of the problem. Undo the corrective action that didn't fix it and go back and try again. All right. Now, one of the things I think is important is when you go in here to gather symptoms and when you go in here to start doing your troubleshooting, a great way to troubleshoot is with the 7-layer model. Okay. Because we're going to look to find the problem. Is it plugged up? Is it running? Do I have blinky lights? And I know that sounds like gathering information, but a lot of it can be, we have no connectivity. Start gathering information from layer 1 up. Okay. Do I have connectivity? No. All right. Am I plugged in? No. Problem may be solved. Yeah, I'm plugged in. I've got blinky lights, but I don't have connectivity. And then you can start troubleshooting. Okay, can I ping my default gateway? Yes. All right, so we got some connectivity. And then you can go from there. You'll notice one of the things you need to do as part of this troubleshooting process is by analyzing the information and things that you gather, you propose a hypothesis. And that hypothesis is what could fix it. And, also take possible causes that could, what could the cause be? My number one question when I walk into an environment that has been working and is not working now is, what did somebody change? What happened during the time it went from not working to working, or working to not working? If someone says, well, we had cleaning people come in this weekend and they moved all the furniture, I'm gonna go looking for cables being disconnected. I mean, that's almost a dead giveaway. Or a cable broken accidentally by a piece of furniture hitting it. So when I go to gather information, one of my questions always is, what has changed? And every single time you go to troubleshooting, somebody's going to say nothing. And then you'll dig down deeper and find out something really did change. Okay. And sometimes not. Sometimes stuff just dies. And if that's the case, then you have to go in here and analyze the information, eliminate the possible causes. Could this be a cable issue? Could it be a NIC issue? Could it be an issue with network traffic? And then you go in and test the hypothesis. If it works and it fixes it, you solve the problem. If it doesn't fix it, again, the most important thing is undo what you did and then try something different. Okay. So questioning your end users. One thing we've got to teach our students is don't be accusatory. Don't be, one of the things we do get a problem with us as tech people is we get frustrated with people who don't know technology. So we need to make sure we speak at a level they understand. And again, try not to be accusatory. Sometimes the problem is between the floor and the keyboard, but we can't tell them that. We have to say, okay, what's the issue? What are you trying to do? Because many times, you'll get a question, I can't get to the internet. All right, hold on a minute. When you say you can't get to the internet, what do you mean? Well, I can't get to the internet. I can't access my email. All right, now hold on. Can you access anything on the internet? And they'll be like, well, yeah, I can get to www.nfl.com. I can't get to my email. All right, now we know there's totally different stories. It's probably not the internet's broke or their internet connection's broke. It's something about their email that's broken. So we've got to be able to ask the correct questions. And then the scope. Is it you or is it everybody in your building? It's just me. Okay, that gives me a very different look than everybody in the building. Everybody in the building, I'm going to start looking for problems that are probably network related or something related to what's connected to that particular building. And that lets us find our scope. Is it a single user? Is it a group of users in a certain area? Is it everyone? Today, our stanley.edu website just got ridiculously slow. And I actually lost connectivity in my S drive. I don't know what happened. We had a little burp and I had to reboot my machine. And it seems like the issues fix themselves, but it was almost like our Office 365 connection had to reset or had an issue today. But that I kind of looked at the problem and I was like, well, I'm not having any issue with any other website, so it's not our internet connection. It seems like it's a connection to our hosted services. Determine when the problem occurred. This is where your logs can help you, especially if you're running some type of logging software. And if you've got your time set correctly, where we talked about NTP last week, having NTP set, having the logs in the time right, so you know when the problem actually occurred. Can you reproduce it? What has changed? And what works, what doesn't work? Here's some of the different commands we can use to gather information. Ping is one I use a lot. Even though I know it only works internally most of the time, it will still give you a lot of information, because if you ping one of the big things, if you go in here and pop me up a command prompt, if I ping www.stanley.edu and it doesn't resolve it, I know that may be a DNS issue. This resolved and ping failed. Well, that's fine, because guess what? I know we blocked ping. Ping www.novell. I know that's crazy, but it will actually resolve novell.com and it will actually reply. So you can actually ping novell.com. Okay. But this shows me that, yes, I can resolve the DNS fully qualified domain name, and I'm able to ping it, so I could probably access it via a web browser. Not always, but probably. Here's my favorite way to troubleshoot, and that's with a layered model, because I think anybody can learn this. Is it plugged in? Does it have blinky lights? And then we get into pinging, trace route, those types of things. The worst problems in the world are those problems up here at the application presentation session layer, those that are in the application area, because it can be something as crazy as a small little API not working with another API. And it could be that in the last update that was a stealth update, you didn't even see the API was changed and suddenly quit working. We had an instance where I have a little program I use to sync my Gmail calendar and my Outlook calendar. Well, for whatever reason, Stanley's antivirus suddenly marked it as a bogus / malware program. So my calendar quit syncing. Well, the bad news is the program would still sync and the antivirus would never tell. Well, the program would look like it was syncing, but the antivirus would stop it and wouldn't even tell you it was stopping it. I didn't realize it until I actually started doing an update on it, and the antivirus tried to block it. So I had to contact support and say, hey, can this be whitelisted? It was whitelisted, everything works fine. But these in-system / application problems are the ones that are some of the worst. They are really bad. I like a bottom-up approach, physical layer up. I will say many times you can just start at the top. So if you go to a web browser, if you go www.cisco.com and I'm able to get there, well, more than likely everything below that's working. So depending on how you could start there if you want to just check it. But once you know there is actually a problem, I troubleshoot bottom up. So I think that's a better way to go. Divide and conquer, I'm not a huge, this one can work sometimes, start, can I ping? If I can ping, then let's try this, go up here. So this one is okay. I think this one for most people is, unless you're an advanced troubleshooter, this one's a little bit harder because you got to understand where to pivot from when you figure out kind of where you start at. Do I go, is this a problem down here or a problem up here? And that is, harder for people who don't have a lot of experience to understand which way to go. Follow the path. These are all just different types of way to find the problem, analyze the symptoms. I like this one, educated guess. You ever heard of a WAG?
No.
Wild ass guess. Pardon my friend. Honestly, sometimes you just take a guess and go, I've seen this before. I've seen something similar, and last time it was this. I wonder if it's related to this. And this is not a great method. But if you're a very seasoned technician and you know what you're doing and you've seen years and years of networking, sometimes you can make a guess and it works. And it fixes the issue. So also like comparison sometimes because it's like, hey, I had the same issue one time before and it ended up being this. Could it be related? And as you look at these different methods, I think as you go from bottom up down this chart here, the more seasoned of a troubleshooter you need to be to use that type of method. Anybody can use bottom up. And it's probably best for everybody to start there. And then as you get more adjusted and you become better as a troubleshooter, you can start using some of these other methods to maybe make things a little faster for you. But never be ashamed to go back to just a simple method. Keep it simple, stupid. So some of the tools we have built in, they can be protocol analyzers. I teach basically a skills for all networking class for a Greenville CTE. And I show a lot of stuff when I'm talking about protocols in Wireshark, things like DHCP, ARP, showing those so they can actually see those packets that are there. So this is a very useful tool, especially out in the real world. Some hardware troubleshooting tools, digital multimeters, cable testers, cable analyzers. All of those are items that we use. We used to do a lot of layer one troubleshooting and cable creation in the academy now, or back in years past. We don't do that anymore, unfortunately. We don't create cables, we don't test cables, those types of things. I think if you have time in your classroom, do it, because I think it's an invaluable skill to be able to know how to create cables and troubleshoot and test cables, even though we all buy them in the real world. I mean,
yeah, we don't make them anymore as part of the class.
No, and I think that's a bit of a shame because I think once you make one, you understand that cable so much better and how it's supposed to work. But I know real world too, we all buy cables. Nobody makes cables anymore, unless you just absolutely need some type of special cable. Syslog is a very good tool, okay, that we can use, and you can actually set up syslogging based upon different levels. And it's important to know, which one of these are. And I think, I don't know if I'm gonna do a lot of this in here because I think we're pretty, again, things to think about: performance, lower than baseline. Physical layer problems typically are obviously cable issues. It could be that you've accidentally run the cable too far for your environment. Most time though, physical layer issues, they don't, once the cable's in place and working, unless something crazy happens, you don't have a whole lot of issues with it. Unless, again, you've got somebody up in the ceiling messing around, putting in IP cameras, doing something, and they mess up a cable. It's possible. But that's something you can look at, especially for noise. You know, if it starts having noise, maybe there's been a motor added somewhere or something else that could cause noise on a physical layer device. Let's see. Here's one I do want to talk a little bit about, and that's transport layer with ACLs. If you are able to do some connectivity, but not other connectivity, so in other words, you might be able to ping, but you can't open a web connection, go check ACLs. Check the ACLs and see if there's something in the line blocking, in the path blocking you from getting to a certain service, a certain port. It could be someone wrote the ACL incorrectly and they're blocking the port that should be allowed. You know, for instance, they may be allowing web access, but not DNS. And so you can't resolve the DNS, and so therefore you can't get to it with a DNS name, but you can get to it with the IP address, things like that. Okay. I think here's a good one to look at, kind of a quick thing. Check your physical layer, make sure everything's connected. You can check for duplex mismatches, which should never happen in the real world now. It's just, if it does happen, it's almost always because somebody physically set the duplex setting and messed it up. In the real world, I haven't seen a duplex issue in an extremely long time. It used to be we would run into them with things like network attached fax machines, some printers, some specialized devices like network attached label printers. Believe it or not, those little things are the devil. But you would get an issue with something like that. It would only support at one time 100 megabit half duplex, or just 100 megabit wouldn't support a gigabit, and a switch port was set to speed 1000. You plug in one of these little label printers and it would never connect because it could only do 100. That's a thing of the past pretty much now. Almost everything supports gigabit Ethernet. So that's not really a big issue. I would, you know, if you're getting down on the ARP table, you're getting pretty deep into, you know, troubleshooting. You may want to check. Now, one thing you do want to check in the real world is port security. So if you're having an issue with a machine, you're plugging in a port, the port goes down, I would check port security. Or let's say you're in the classroom, everything's working fine. You boot up VMware Workstation or VirtualBox to open up some virtual machines, and then the machine suddenly gets knocked off the network and the port's amber. It's probably a port security issue. So you've set it to a maximum of 4 addresses or 3 addresses. And when you booted up all those virtual machines, they all had their own individual virtual MAC address, and pop, you hit port security and it shut itself down. Right? VLAN assignments, you know, those types of things, default gateway. This is 99% of the time when there's default gateway problems, you fat fingered it in the DHCP server settings, or you fat fingered it when you put it onto the physical machine itself. So instead of putting 10.1.10.1, you may actually put 10.1.100.1, and that's not the correct gateway for the network that you're on. Many troubleshooting issues are the result of fat fingering things and just putting in. And trust me, when I'm working in the lab environment, there have been so many times when I literally fat fingered something by one number, and the one that kills me is 192.168. I'm bad to put 192.16 and miss the 8. And so if you know that's something you have an issue with, and it seems like it's just a weird random problem, go check the IP addresses because you probably screwed those up. If the environment allows ICMP, you can run trace route, because remember, the ability to do a trace route depends upon the ability to have ICMP send out echo requests with a TTL of 1, come back, TTL 2, come back up to 30. If you cannot use ICMP, then trace route won't work. All right, so just be aware of that. Let's see, anything in here I kind of think about now. Again, your ACLs that show IP access list, show IP interface will show you if there is an access list set, and then correct the issue. Maybe you got it going in the wrong port, or you forgot to assign it to a port. That happens many times with access lists. You create it and forget to assign it. That's pretty much it on chapter 12. There's not a whole lot to it, honestly. Do you have any questions for me, Angela?
No, I mean, it's like you said, it's a good review of the OSI model and just in troubleshooting like we do in networking essentials. So
Yeah. I'm not really going to spend a whole lot of time on the virtualization chapter because I think it's something that you can kind of read and get for yourself. I do think the big thing here that many people have not heard of before is called VRF, and they don't even really talk about it in here. They're dealing with type 1, type 2 hypervisors. They are looking at virtualization on the server end more than on the router itself. There is a way, though, to actually on the routers create what are called virtual routing and forwarding. You can actually take a router and create chop it up in almost like VLAN. So there's different routing tables for different virtual VRFs. They're called VRF Lite and VRF. But they don't really mention that in here. This is more just an overview of basic virtualization. So type 1, type 2, bare metal hypervisors, which is type 1. Type 2 is hosted hypervisors. A hosted hypervisor is something like VirtualBox, VMware Workstation, those types of things. So you can have one hosted on an operating system, and then you can load things inside of that. The type 1 hypervisors, the most widely known one is ESXi, which obviously Broadcom has caused a storm with their purchase of VMware. And so a lot of people are talking about VMware. There are others out there, though, type 1 hypervisors, KVM, Proxmox, Hyper-V. All of those have the ability to do what are called bare metal hypervisors. And that is the most efficient way to do virtualization, because you literally load the hypervisor and it serves as the layer between your hosted operating systems and the hardware that's below it. So it's a pretty easy thing to do. Here's an example. This is a Cisco UCS manager. Cisco makes their own servers, and those UCSs have all kinds of detailed management options and those types of things. And this is similar to a thing that Dell has, which is, oh God, I'm just drawing a blank. Not Optiflex, but basically there's a management thing like this for all of our Dell servers. We pull our Dell servers in and can look at everything on the Dell server, everything from fan speed, etc. The one time I worked on a Cisco UCS, we had one in our environment. It was a great system. This was years ago. This was like 15 years ago. But they shipped it in, and it literally came in like 7 boxes, and we had to put it together ourselves. It did not give me warm fuzzies when I had to put it together myself. When I put what we paid for that server, we use mainly Dell and Lenovo servers now for our virtualization. Okay. The one thing I will and do want to talk about during this virtualization is a concept that is kind of, I won't say foreign to us, but a little different. And that is this concept of north-south versus east-west traffic. In a data center, and in most networks today, honestly, most networks today, traffic's north-south. It's from the network out to something and back in. If you have a big enough data center, though, you're going to have what's called east-west traffic. and that's traffic between your different servers in your environment. Many times you take east-west traffic and even put it on a different network on the back end, so it is not impeded by your north-south traffic, or the north-south traffic and the east-west traffic aren't being in competition with each other for bandwidth. You also, the east-west traffic gives you some real different security issues, because you need to be able to control traffic from one virtual machine to another virtual machine through a virtual switch. And you can do that through virtual firewalls, and you can do that through other ways inside the virtual switches with some ACLs inside the virtual switches. But be aware, in a data center environment, that east-west traffic is that traffic between your servers in your data center. And then north-south traffic is traffic out to different resources that are available externally. Well, that's really all I had for today. Do you have any other questions for me, Angela? Anything that's popping up as an issue for you?
No?
Okay. Let me stop the recording here.